Good evening, ladles and spoons. We're running a double-blind experiment tonight. Neither you nor I are going to know if the jokes are going to be funny. Help me out. How many of you are here for the science?
Oh, yes.
Yeah. How many of you are here for the comedy?
Yeah!
Pressure's on. And how many of you are here because you took a wrong turn at the gift store? Okay, introductions. My name is Paul Mason, and as you can tell from my moustache, I am gluten intolerant. But when it comes to science, I'm in good company, or my moustache is in good company. Ernest Rutherford, a rather glorious upper lip, although I do understand he suffered from split hairs. George Washington Carver went from slave to scientist. He had a very well-grown, well-weeded moustache. Marie Curie, her moustache positively glowed. It radiated with achievement. Tycho de Bray, very astronomical moustache. Tu Yu, her moustache was so big it scared mosquitoes away. Rosalind Franklin sported the very first double helix moustache. And apparently when the boys found out about it, they stole the idea. If you know, you know. Camillo Golgi had a moustache that he would stain regularly. And Margaret Mead didn't always have a moustache. In fact, she only got a moustache once she came of age in Samoa. I'd like to share with you my own coming-of-age story. My mum, when she first arrived in Australia, she arrived in Fremantle, actually. And she, when I was growing up in Australia, she would tell me a lot of the stories of her experiences under the Japanese in a prisoner of war camp in Indonesia for 3.5 years. And I also had 2 older sisters. So I was made acutely aware of the privileges and opportunities afforded to me as a boy growing up in Australia. So I didn't want to sit back and just passively benefit from my white male privilege. I wanted to make a difference in the world. I wanted to make the world a better place. So I decided to become a scientist. When that didn't work out, I decided to become an anthropologist. When that didn't work out, I decided to come here tonight. A common thing happens when anthropologists tell people that we study anthropology. People sometimes make the understandable mistake that we study ants, beetles, and other insects. And because I'm the last of 3 children and have a desperate need for attention, I'll just run with the idea. I'll happily regale people with fun and interesting facts about ants, beetles, and other insects. In fact, I've gone so far as to make my own board game about dung beetles called Hexcrement. Copies are available for purchase after the show. Now, I'm here tonight, ladies and gentlemen, to tell you about Neanderthals. Anthropologists study humans and our close relatives. And Neanderthals are really interesting to know about because understanding a little bit about our Neanderthal ancestry can explain something about the diseases that we are protected from, the autoimmune conditions that we are susceptible to, and why some people don't feel ashamed wearing Crocs with socks in public. What can I tell you about Neanderthals? Well, for a long time, scientists didn't know if Neanderthals and humans were related and part of the same species, or if we were completely different species. Neanderthals looked sufficiently like us. In fact, if you saw one on a bus, you probably wouldn't give them a second glance, particularly not if they're wearing an Eagles jumper. They were shorter than us, muscly, they were red-haired. I find that's hilarious because somewhere in our family tree, someone decided to bring a little bit of ginger into our ancestry. Don't know if that was a good idea. Now, Neanderthals had a comparably big brain, like us. Their skull was a little bit different in size and shape, but on our skull, we actually have a few remnants of our Neanderthal ancestry. So if you do this with me now, feel that bump at the back of your skull. That's called the occipital bun. In phrenology, that's called the inion of knowledge. Mine's really huge. Now, in order to tell you about how we may or may not be related to Neanderthals, I need to tell you a little bit about hybridization in other animals. So if you were to take a male zebra and interbreed it with a female donkey, you would get the confused love child of nature known as a zedonk. It's kind of like a donkey went to wear a zebra onesie, but just settled for zebra socks instead. If you took a male camel and interbred it with a female llama, then it's as if nature said, well, here's your payback, karma. A camel that forgot how to be useful, and a llama that's too tall to spit accurately. Our last example, if you take a male polar bear, very carefully, try to interbreed it with a female grizzly bear, well, you end up with something equal parts fluffy and ferocious. Let's just say in man versus bear, everyone's choosing the pizzly. Guys, imagine coming back from a walk in the forest, missing an arm, with a slashed arm, slashed legs, cuts all over your body, and then telling your friends, I got attacked by a pizzly. Very embarrassing. All right, so let's turn to the scientific evidence that we have from Neanderthal fossils and from humans. Let's first turn to our nuclear DNA. Nuclear DNA is the DNA that you get from both your parents. So you might get your dad's ability to crack bad jokes, but you'll also get your mum's ability to roll your eyes at him. Now, when we look at our nuclear DNA, we have anywhere in our genome, anywhere up to 4% contribution of Neanderthal DNA to the human genome, which is a massive amount of Neanderthal DNA in our genome. That's the equivalent of a great-great-great-grandparent's contribution to our DNA. That's quite significant. But let's move to other forms of evidence that we have available to us. Let's look at our chromosomes. Now, you get most of your chromosomes from both parents. The X chromosome comes from the maternal line, and Y chromosomes are exclusively paternally inherited from father to son. And strangely, the Neanderthal Y-linked genes didn't make it into our gene pool. So it kind of looks like Neanderthals tried to crash the human party, but the Neanderthal boys didn't make it past the bouncer. Last piece of evidence comes from our mitochondrial DNA. Now, mitochondria is the energy powerhouse inside every cell in your body, and you get your mitochondrial DNA from your mum, because if you got it from your dad, he wouldn't shut up about it. That's true. Now, the interesting thing here is that humans do not possess any mitochondrial DNA from Neanderthals, which is really strange. So we've got nuclear DNA from Neanderthals, but we don't have any Y-linked genes from Neanderthal boys, and we don't have any mitochondrial DNA from Neanderthal women. So how do we piece all those pieces of evidence together? Well, in order to do that, I'll need to tell you one more thing about hybridization. I need to tell you one more thing about hybrids. Oops, not those hybrids. These hybrids. In hybrid pairings, the female offspring are almost everywhere. They're predominantly female. But where are the male hybrid offspring? Well, they're a little bit like the Wi-Fi at that dodgy Airbnb. Patchy, spotty, on the blink, and probably wasn't working in the first place. So hybrid offspring are mostly female, and the boys are absent, rare, or sterile. So when we apply that logic to the available scientific evidence, we arrive at a hypothesis that male Neanderthals were able to interbreed with human females, but not the other way around. That the opposite was unlikely to occur or didn't produce any viable offspring. So we can no longer really think of ourselves as a single purebred species. Rather, we should think of ourselves as humans. Now, I chose to tell you about a hypothesis tonight because this could all be disproven tomorrow. This could all be proven wrong tomorrow. And I chose to tell you about a hypothesis because when scientists are given a microphone and put into the limelight, we're often seduced, a little bit like Newman's great-great-great-grandma, to regale audiences with fun and interesting facts about science. But that's not how science works. Science is not just about generating facts, it's about testing hypotheses, about taking an idea and seeing if it's falsifiable. Selling the public on the idea that science is this repository of bulletproof knowledge risks undermining public trust. It's a little bit like thinking you can make a short, quick trip to IKEA for that perfect item, only to find out it's going to be a 6-hour grueling test of your will and a descent into hell that's going to end with divorce. In public culture, we like to celebrate scientists as walking Wikipedias, as intellectual giants. But let me clue you into a little secret. Scientists are not actually smarter than the rest of the population. Scientists are just more comfortable with feeling stupid. In the industry, we don't call that being clueless, we call it productive stupidity. Real breakthroughs don't come from knowing all the answers. Real breakthroughs come from embracing how little we know. And in science, we get to do really great things. We get to take ideas that appear inevitable and unavoidable on the surface, things like patriarchy, standardized education, capitalism, and treat them as experimental ideas that can be proven wrong. So thank you very much for letting me tell you about my hypothesis about Neanderthal human hybrids. I'll be back next week to talk about ants. And if none of this made sense, don't worry, just remember it's all hypothetical. And on that note, I'll leave you to test your own hypotheses. Thank you very much.